Today we're looking at another graph that shows how data is distributed or spread out. And this graph is called a box and whisker plot. And again, a big part of the reason people use a box and whisker plot is because it very easily summarizes how the data is spread out. And it separates it basically into 4 sections, and then you can see within those 4 sections is the data relatively more spread apart or relatively close together. And when we look at a box and whisker plot, there are 5 key numbers we look at. It's called the 5-number summary. We have the lower extreme, which is the lowest number. We have the upper extreme, which is the highest number. And then we have the median, which is the middle of all the data. And then further we split it down into the first or lower quartile and the third or upper quartile. And those are the medians of the lower and upper halves of the data. So you can kind of envision it like this, basically. If this is our first number and this is our last number in our set of data, think about it like this. What we're doing is we're splitting our data in half, and then we're splitting each of the halves in half. So when we look at it, whichever number comes first is our lower extreme. Whichever number comes last is our upper extreme. Our median is the middle of the data. Quartile 1 is the middle of the lower half, and quartile 3 is the middle of the upper half. And so that's really what a 5-number summary is referring to. Now when you look at that, yes, it's 5 numbers, but when you look at that picture, you should see that really what we're doing is we're splitting the data into 4 parts. So each part of the data, or each part of the plot rather, represents 25% of the data. So each section from the lower extreme to the first quartile, 25% of the data is contained in that section. 25% of the data is contained between the first quartile and the median, so forth and so on. So let's take a look at what a box and whisker plot actually looks like. This is an example of a box and whisker plot. And when you look at this, again, I want you to see that there are 4 sections. Here's the first section, so this represents 25% of the data. Here's the second section. That represents 25% of the data. The third section, that represents 25% of the data. And the last section represents 25% of the data. So they're not all the same size. And the reason they're not all the same size is because the first fourth of the data is much, much closer together, for example, than the last fourth of the data. Those 2 parts are called the whiskers, by the way. These pieces here and here are called the whiskers in our box and whisker plot. The whisker that represents the lower half of represents the first 25% of the data is much shorter because that 25% of the data has less variability. It's closer together than the upper fourth of the data, which is represented by our whisker that's on the right-hand side. That data is much further spread apart. This center part from the first quartile to the third quartile is called the box, and it's because obviously it's shaped like a box. So let's take a look at this and identify our 5-number summary. The lower extreme is 2 because it's the lowest number that's plotted. It's right here. The upper extreme is here, 10. The median is represented by the line that splits up the box, so the median is 4. The first quartile is 3, represented by the left side of the box, and the third quartile is represented by the right-hand side of the box. It's at 7. The range of all of the data is 8 because the upper extreme is 10 and the lower extreme is 2, so the range is 8. It's from the largest to the smallest number. The interquartile range, or IQR, basically measures the box, so it's the difference between quartile 1 and quartile 3. So we would do, for that one, we would do 7 minus 3, and our interquartile range would be 4. All right, let's take a look at another one and see if you can figure out what's what in this particular box and whisker plot. Take a moment, pause it, and see if you can figure it out, and then we'll move on. You can move on when you have got it solved. All right, here are what your answers should be. We see where our lower extreme is 0, upper extreme is 9. Remember, it's not 10 because we're looking at the numbers that are actually represented by the ends of our whiskers. Median is 5, represented by that line that goes down the middle of the box. First quartile is 4, represented by the left side of the box. Third quartile is 7, represented by the right side of the box. Range is 9 because the upper extreme is 9, the lower extreme is 0. 9 minus 0 is 9. The interquartile range is 3 because the third quartile is 7, the first quartile is 4. 7 minus 4 is 3. So now that we know what the parts of the box and whisker plot are, let's take a minute to see how we actually make a box and whisker plot. Take a minute to read through all the steps. There are quite a few of them. Read through all the steps, and then we can look at this a little bit closer. All right, now that you've had a chance to look at that, let's go ahead. You may want to refer back to that. So if you want to write our next pieces of data that we're going to work with, write those down and then come back to this so that you can look at the directions while we do it. That's perfectly fine. So our first set of data, the first thing we're going to want to do is put this in order. So we're going to have 19, 20, 23, 26, 30, 32, 38, and 42. Now, the first thing that it says in our set of directions is that we want to choose a scale for our number line. Looking at our number line, you could always number by 1, but sometimes that's not as practical. I would number by 2 because this data is spread apart enough that that just makes it a little bit easier to deal with. So since our first piece of data is 19, I'm going to start numbering at 18 and 20, 22, so forth and so on. Now, if your data were more spread apart, certainly you could choose a larger number to count by. That would certainly be okay. Now, the next thing we need to do is find our 5-number summary. And when we do that, the first thing we're going to look for are our extremes. So our lower extreme and our upper extreme. Our lower extreme is 19 and our upper extreme is 42. The next thing we look for is the median of the data. So our median, we would say, well, it's not 19 or 42. It's not 20 or 38. So we're working our way in, not 23 or 32. And we would say not 26 or 30, but if it weren't those two, well, then there wouldn't be anything left for it to be. So instead, it has to be between those two. Remember how we find the median? We can add together 26 plus 30, which is 56. Divide that by 2, and you get 28. So the median is 28. 28 is exactly in the middle of 26 and 30. Then we need to find quartile 1 and quartile 3. Quartile 1 is the median of the lower half of the data. So we're only right now looking at these numbers, and we want to find the middle of those numbers. So it's not 19 and 26, and we would say not 20 and 23, but it has to be right in the middle of those because there's two numbers there in the middle. Well, 20 plus 23 is 43, and half of 43 is 21 and 5/10. So the median of the lower half of the data, which is quartile 1, is 21 and 5/10. Now looking at the upper half of the data, when we look at that, from 30 to 42, it's not 30, not 42. We would say not 32 and not 38, but then there's nothing left. So again, our median falls between the two numbers. So 32 plus 38 is 70. 70 divided by 2 is 35. The number that's halfway between 32 and 38 is 35, and that's our third quartile. So we're going to go ahead and graph all 5 points now. Lower extreme is at 19. Upper extreme is at 42. Median is at 28. Quartile 1 is at 21 and 5/10. So I'm going to have to think about that one a little bit. Here would be 21, so 21 and a half would be right about there. And then the third quartile is 35. Then I'm ready to start connecting. The box is going to go from the first to the third quartile. So here's my first quartile, here's my third quartile. I'm going to connect those to make a box. And that dot that's in the middle, that's where my line splits up the box into two parts. Whisker from the lower extreme to first quartile, and then from the third quartile to the upper extreme. So there's our first box and whisker plot. Notice when we look at that, our data really is pretty evenly distributed because all the parts, the four parts, are all about the same length, except for the first fourth of the data. That part, that whisker, is much smaller than the other parts of the box and whisker plot. So that means that the first fourth of our data is closer together than the other fourths of our data, than the other parts. All right, looking at another set of data. When we're going to make this one, put our numbers in order. So 12, 15, 15, 16, 17, 18, and 36. Now, when you look at this, you may say, well, all that's pretty close together, especially the 15 to 18 part. 12 is still pretty close to that, but that 36 is way different. Well, watch and see what that does to the shape of our box and whisker plot. I'm going to look for a scale. I have to go from 12 to 36, so it still looks like this is probably a pretty good candidate for counting by twos. I'm going to start with 10 because really I don't like to start with the number that's going to be our lower extreme. Not that you can't, that's just sort of a personal preference thing. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. Now I need to do my 5-number summary. So my lower extreme is 12. My upper extreme is 36. The median of this data is not 12 and 36, not 15 or 18, not 15 or 17. 16 is the median of my data. So 16 is the median. Now when I go to look at the first quartile, something really important to notice is since 16 is our median, it's exactly in the middle. It's not part of the upper half of the data, and it's not part of the lower half. It's exactly in the middle. So we don't include it in either the upper or the lower half when we're finding the first and third quartiles. So our lower half of our data is from 12 to 15. It's these numbers right here. So our median of the lower half is not 12 or 15, not the second 15 anyway. It's that 15 right there in the middle. So quartile 1 is 15. And quartile 3, if I look at my upper half of the data, it's not 17 and 36. It's going to be 18 for my third quartile. Now, when I go ahead and do my graph my points for my 5-number summary, I'm going to have a lower extreme at 12, upper extreme at 36, median at 16, first quartile at 15, and third quartile at 18. And when I make the box and whisker plot, box goes from the 15 to the 18. I'm going to split the box at the median, which is 16, and then connect my upper and lower extremes to make my quartiles, or to make my whiskers, rather. Now, looking at that, the fact that 36 is an outlier, that makes sense considering when I look at the box and whisker plot, all the data is pretty well scrunched together, except for in that last section, which is much, much longer. That whisker is much, much longer even than all of the rest of the data. So that shows that the data in that section is much more spread out. And so it is, because it goes from 18 all the way to 36. So it is a lot more spread out than the other data. Now you might be asking, what in the heck? Why is this helpful? What's the point? Well, let's take a minute to look at some examples. So looking at each of these box and whisker plots, what can it tell you about the data that was used to create it? Now, what it cannot tell you is it cannot tell you what all the data is. One reason is because certainly these don't have number lines with them, but even if they did, we could not know what the original data is because we don't know, first of all, how many pieces of data were used to create it. And even if we did, that would only tell us we could only know the lowest and highest numbers, not how many there were of that number or how many of the median or really any of those things. So We cannot tell what the original data was or how many pieces of data there were. What we can tell is how the data was grouped. This blue one, for example, because the first whisker is so small, we can tell that the first fourth of the data was really, really close together. The next fourth of the data was also really, really close together. So those two sections together represent the lower half of the data. It was really close together. The other two sections represent the upper half of the data. Here's my next 25%. Notice that that section actually even by itself is probably bigger than the other two sections put together. So that 25% of the data is more spread out than the lowest 50% of the data. And then our highest 25% is much more spread out than any of the other sections. So that's what we can see about that one. The red one is the exact opposite. The first section, the lowest 25%, is very, very spread out. And then the data starts to get closer together the higher we go. The green one, that one is more evenly spread somewhat, but what it does show us is that probably the data is clustered at the low end and the high end because that's where the data is the closest together. So there's probably a cluster here. And really, I could go back to the red and blue ones and talk about clusters there as well, because the parts where the data is close together, those are clusters. So certainly I would say the data is clustered here, and the data is clustered here for sure, because it's much, much closer together there than it is in other parts of the data. And then for the green one, the middle 50% is much more spread out because the box is much bigger than the two whiskers put together. And then the last one shows my data pretty evenly distributed because each whisker is about the same length as each other, and each whisker is also actually about the same as each half of the box, the same length. So that means I have data for that one that was very evenly distributed. Now looking at this in context, if these were two different classes, Class A and Class B, those represent our scores for our students, and we can certainly see that Class A, the data was way more clustered. It was much closer together. Class B had a lower score in it than Class A did, but it also had a higher score than Class A did because I can see where the lower extremes and the upper extremes are. The data is far more spread apart for Class B, and I can see that because the length of the box and whisker plot is much longer. Another thing I can see is that 75% of Class B scored higher than anybody in Class A. And I can say that because 3 out of 4 sections, or 75% of Class B, is higher, equal to or higher than the upper extreme of Class A. So I can certainly see, if I were trying to figure out which class did better, I would certainly say Class B. Although there are some people who didn't do great in Class B, overall, Class B scored much, much higher than Class A. I can see there was more variability in the data for Class B. So certainly there were some very low grades, but there were also some very high grades. Class A, they were much closer together. They weren't very good, but they were much, much closer together. Hopefully looking at this has given you an idea of how to make a box and whisker plot, what the parts are of it, and kind of what the purpose is in terms of seeing how the data is distributed. And hopefully as you look at these, you would be able to see how the data is distributed by looking at a box and whisker plot.